Okay, guys, now we're into Unit 3 where we're going to be talking about rates, proportion, scale factor, and percent. So a calculator will be helpful. And remember, pause the video at any point you need when you're taking notes. A rate is a ratio that compares two different units of measure, such as miles per hour or inches per second. When working with rate, the words per, for, and each are often used to separate the units. You can see in our example, miles per hour, inches per second. A unit rate, which is a type of rate, it is when the denominator is a single unit of one. Therefore, to determine the unit rate, divide the numerator by the denominator. This is why a calculator will be very handy. So we have a rate, which compares two units of measure. And then if we want to know the unit rate, we divide our numerator by the denominator. So let's look at some examples. We have 108 green M&Ms in 9 bags. So that is a rate. Now to identify the unit rate, we will divide by 9, and we're going to get 12 green M&Ms per one bag. That's the unit rate. We have 36 centimeters per 4 seconds. To identify the unit rate, we're going to divide by 4, and we get 9 centimeters per 1 second. We have earned $700 in 40 hours. To find what we make per hour, we divide by 40, and we make $17.50 per 1 hour. Pause the video, practice these problems, make sure you set up your rate and then find your unit rate if you need to. Round to the nearest tenth. Okay, now let's talk about unit prices. Unit prices provide the cost per one unit. Knowing the unit price is helpful in finding the best deal. So note, to find a unit price, you always divide the cost by the item. So we're going to write that. Divide the cost by the number of items. So let's find the unit price, for example 4, to see which one is a better deal, how much each bottle of water cost. So we're going to have $13.80 divided by 12 bottles. And when we divide that in our calculator, we get $1.15 per bottle. If we have $22.80 for 24 bottles, we divide this, and this is 95 cents per bottle. Therefore, our second option is the better deal. Example number 5, we have $7 for 20 ounces. This is going to give us 35 cents per 1 ounce. We have $3.20 divided by the 8 ounces, and the unit price is 40 cents per ounce. So choice 1 is the better deal. So that is unit price So practice these problems, setting up your ratios for each and get that unit price and then indicate which choice is the better deal. Okay, now let's take a look at different ways that we can refer to unit rate. Unit rate is also referred as the constant of proportionality where the variable k is used and the constant rate of change where the variable m is used. So unit rate, constant of proportionality, and constant rate of change all mean the same thing. When representing and calculating unit rate in tables and graphs, divide the output values y by the input values x. So unit rate is going to be y divided by x. If we use the variable k, k equals y divided by x. That will be our unit rate. Or if we use m, y divided by x. Now let's take a look at some tables and graphs. So here we have an example. We have $3.50 per 7 ounces. Let's find the unit rate and complete a table of values. And then we will graph this. So we're talking about ounces of ice cream and the cost. So to find the unit rate or the unit price, so for 1 ounce of ice cream, it is going to cost us 50 cents. So our X values are going to be ounces. Always establish what your X and Y is, and Y is going to be your total cost. So let's just start with at 0 ounces, we pay 0 money. At 1 ounce, we pay 50 cents. At 2 ounces, we pay $1. 3 ounces cost $1.50. 4 ounces cost $2, and so forth. So now let's graph these. So our X values are along the X axis. So at 0 ounces, we pay $0. For 1 ounce, we pay 50 cents. 2 ounces is going to be $1. 3 ounces, $1.50. 4 ounces, $2. And we can keep going. And you can see how it creates this straight line. When we have a line such as this, we have a constant rate of change. And I can actually connect these because you can have partial ounces and partial money. Okay, so this is an example of a function table and a graph representing unit rate. Okay, pause the video, find the unit rate for each of these. Make sure you label what your X and Y values are. Let's always start with 0, 0 is our first ordered pair. Graph your ordered pairs and connect the points if needed. Now let's take a look at when we are giving a graph and how to find the unit rate from a graph and create our function table. So this example is gallons and miles. So we have miles per gallon. So I'm going to write miles, the Y, per gallon. Okay, so remember K equals our Y over X, our unit rate. So X is gallons, Y is miles. I'm going to start with 0 gallons. I go 0 miles. Okay, let's pick any ordered pair. So I'll just pick, this looks nice. So this ordered pair, 2, 20, we have gallons and we have miles. So to find the unit rate, we're going to take the 20 20 miles divided by the 2 gallons, and this gives us 10 miles per gallon. So for every gallon of gas we use, we can go 10 miles, or we can say for every 10 miles we travel, we've used 1 gallon of fuel. So now let's just start, and with 1, okay, this is our unit price or our unit rate. I'm not talking about price here. So our unit rate for 1 gallon, we can go 10 miles. We don't really need to put the unit since we have it here. And then for 2 gallons, we go 20 miles. 3 is 30. 4 gallons takes us 40 miles. And if we go 50 miles, we've used 50 gallons. And we can draw the line, you can see, is all the way through, because you can have partial gallons and partial miles. Okay, now let's look at our last example. This time we are given a function table and we want to know the unit rate. So our unit rate is going to be sodas per day. So we have 0, 0, we always start there. And now let's just take a look at our first given ordered pair. So we're going to say K is equal to 5, okay, the number of sodas. So 5 sodas in 2 days gives us a unit rate of 2.5 sodas a day. So this is the student soda consumption. So our X values are days, our Y is total sodas that we drink. And now let's graph. We can start out with, in 1 day, it's 2.5, so this would be 3. So 2.5 would be about right there. So I'm just going to graph the ones that are here. So 2, 5, and then I have 4, 10. I have 5, 12 and a half, 7, 17 and a half, and I can see that I'm graphing correctly because it's creating that straight line. And then 8 is 20, and I can't graph the other one, it's off the chart, it would be somewhere up here. And you can have partial day and you can have partial soda, even though it would be flat if you waited to the next day. And there we go. This shows our unit rate. We have 2.5 sodas in 1 day on average. Okay, you finished the rest of these problems. Make sure you include what each X value represents. You can just look along the X axis right here, and then the Y values. And then just remember that unit rate K is the Y divided by the X, the output divided by the input. When you're finished, make sure you check the answer key, making all corrections. So check, reflect, and correct before moving on to the concept check.